Determine the equations of the tangent line to the circle x squared plus y squared equals 61 at the point where x equals -5. Meaning, we have a circle which is centered at C, and we have to obtain the equation of this line which is tangent to the circle, let's say at point A, with the coordinates. The x coordinate is given to us, the y coordinate is not given. So we'll suppose that the y coordinate be B. So let's try to obtain the equations of the tangent line. So here we will start with the equation of the given circle. So we have x squared plus y squared equals to 61, but we'll transpose 61 to the left hand side. This will be equals to 0, and we're going to compare it with the general equation of a circle. G will be equals to 0. F value will be equals to 0 as well. And here C value will be equals to -61. Now that we have the value of G, F and C, we can easily obtain the equation of the tangent line by using the point form. So let's also recap the point form of a tangent line. The point form of a tangent line is given by x times x1 plus y times y1 plus g multiplied to x plus x1 plus f multiplied to y plus y1 plus the constant c equals to 0. So this g, f and c are the values of the constants which can be obtained from the equation of the circle. Now x1 comma y1, that is going to correspond to the point of contact. In our case, x1 comma y1 corresponds to the point A with coordinates -5 comma b, which means that x1 will be equals to -5 and the value of y will be equals to b. So we'll substitute this into a point form, so we get -5x plus b times y. So here g and f are 0, we have the value of c, so that's -61 equals to 0. Or we can multiply throughout with -1 to get 5x minus by plus 61 equals to 0. We're going to name this equation number 1, and this is going to be the equation of the tangent line. Now, in order to find out the value of b, which is only going to then help us find out the equation of the tangent line, we will drop a perpendicular from the center of the circle to the tangent line. And by definition, this line is always going to be the perpendicular to the tangent line. And so here, CA is nothing but the radius of the circle. Now, we will need one more information, that is the coordinates of the center of the circle. Now, using the value of g, f and c, we can immediately find out the center as well as the radius of the circle. So let's do that. So here, the center is going to be defined by -g comma -f. Clearly, g and f are 0, so that means our circle is centered at the origin. So we have 0 comma 0. Now to find out the radius of the circle, we're going to use the formula square root of g squared plus f squared minus c. So here g and f are 0, the c value that corresponds to -61, so our radius comes out to be square root of 61, positive 61. So we have the radius as well. Now, there's a formula to obtain the distance, the perpendicular distance of the point C from the straight line. So let's walk through that particular formula. Let's say we have a point having the coordinates x1 comma y1. And then we have a straight line with the equation ax plus by plus c equals to 0. Well, if we join the point and drop a straight and a perpendicular line on the straight line, then this perpendicular distance will be given by the formula ax1 plus by1 plus c whole divided by the square root of a squared plus b squared. Now in our case, we have the coordinates of the center C with the value 0 comma 0. We have the perpendicular distance as well as square root of 61, and we have the equation of the tangent line, which is 5x minus by plus 61 equals to 0. We can use this formula to get CA will be equals to, we'll take the absolute value. Now we will start with the coefficient of x of the tangent line, that's 5. Y will get multiplied with the x coordinate of the center, that's 0. Added to the coefficient of y, which is -b, and this will get multiplied with the y coordinate of the center, that's 0. Added to the constant value 61, divided by the square root of coefficient of x, which is 5, we are going to square that value and add it to the square of the coefficient of y. So that's going to be b squared. Now the value of CA, that's going to be the radius of the circle, which is square root of 61. So that will be equals to, we have 61 divided by square root of 5 squared plus b squared, and we have to take the absolute value. Now we will square both sides to get 61 equals to 61 whole squared divided by 5 squared plus b squared. Now we can factor out 61 from both sides, and that's going to give us 1 equals to 61 over 5 squared plus b squared. Cross multiplying gives us b squared plus 25 equals to 61. So b squared is going to be equals to 61 minus 25. So b squared is 36, which means that taking the square root we get plus or minus 6. So we have the corresponding b value. Now that we have the value of b, we can substitute this into our equation number 1, 5x minus by. So equation number 1 is 5x minus b times y plus 61 equals to 0. So when we consider the b value to be equals to positive 6, this is b times y, then 5x minus 6y plus 61 equals to 0. And when we consider b to be negative 6, then we get the other equation, bx plus 6y plus 61 equals to 0. So these are the two equations of the tangent to the circle x squared plus y squared equals to 61 at the point where both x value equals negative 5.